Thank you, Governor, and friends and colleagues, and ladies and gentlemen, students. It's great to be back here in Rhode Island. This is a wonderful place to be any time of the year. It would be nice if it was a little sunnier, but it's great to be here today. I look up at the ceiling and I see all these planes hanging and pictures of airplanes around on the walls, and it is inspiring to me, hopefully to you, and hopefully it is indicative of an interest in aviation. I'd like to set the stage by talking about national issues. There are very significant strategic issues that we as a country face. If we think about the world today, we don't have enough scientists, engineers, mathematicians going into the workforce. All of you, those of you who are students, are part of what we would characterize as the science, technology, engineering, mathematics pipeline. We need more of you to engage in those fields and to be part of that workforce in the future. Why is that important? Well, if we look at the numbers of people that we have in the aerospace and defense workforce as an illustration, about 54% of the total workforce is 45 years old or older. About one third is eligible to retire today. If we look at the numbers of people going into baccalaureate programs across the United States, about 7.5% go into engineering. Of that 7.5%, only half graduate with a degree in engineering. So we really don't have enough people in that pipeline to satisfy our workforce requirement. If we don't, think of organizations like the Department of Defense and others who are engaged in national security. We don't have enough people to satisfy that workforce requirement for national security. If we don't, our national security as a country will be at risk. The only ones who can help solve it are all of you who are the students in this country. We need you to be engaged and be involved. If we look at the commercial side of science, technology, engineering, and mathematics, we've all heard about outsourcing and this global economy that we're all engaged in. It's true, we can hire an engineer in India or China or other low-cost labor environments at 25% of what it costs in the United States. That begs the question of what do we need to do to prepare people for this global competitive marketplace? I would argue that we need to prepare people that are 4 times the value of people in those other countries in order to be competitive globally. Well, what does it mean to be 4 times the value? I would suggest that it means we have to prepare people that are better innovators, more adaptive, and able to manage complex engineering and design programs. And if we can do that, I think we can be very competitive in that global marketplace and have people who are 4 times the value. The goal of the Real World Design Challenge is to help address that kind of workforce need, to prepare people who can be 4 times the value of those others in other countries. And I think all of you are ready for that kind of workforce challenge. We need to prepare you for that. The Real World Design Challenge addresses that. Why did we come up with the name Real World Design Challenge? Well, we've been looking at this workforce problem. We've been studying it. We had a number of conferences that where we brought together people at the National Academy of Engineering, on Capitol Hill. We talked to policymakers. We had a forum with aerospace and defense companies here in New England. And we asked them, what do you want in the workforce? We looked at the numbers and they looked dire. But we wanted more color, and they told us 2 things that were particularly interesting. We want people that have excellent academic credentials and experience, so stay in school and keep working in school, that's important. And they wanted people with 7 to 10 years of real-world experience. That floored us, because that adds a decade on the pipeline, which we don't have. So we asked them, would it be possible to infuse the real-world experience at the K-12 and possibly undergraduate levels? Their answer was yes. That told us something interesting and strategic. If we developed a program that infused real-world experience at the K-12 level, et cetera, we could cut a decade off the pipeline. So that was our goal when we established this challenge. It's real-world in several ways. I'll get to that in a minute. Why design? Well, design is a core part of the process of doing engineering. It's a way of understanding, the design process is a way of understanding the world and solving problems. It's a way of teaching innovation. And remember, that's what we need for the workforce, to be 4 times the value. So we want to be able to teach innovation. So we came up with the name Real World Design Challenge for those reasons. Now, what do we mean by real world? 4 things. First, a challenge defined and designed by industry, so that it's cutting edge and a problem that is current and one that has yet to be solved by the professionals. Second, the students get to use professional tools, the same software tools that the professionals use in doing their engineering work. Third, the students, teachers get $1 million worth of professional engineering software. So that's kind of a good deal. Third, the students get to engage in real roles, the same kinds of roles the professionals engage in: project manager, project scientist, project engineer, project mathematician, marketing communication specialist, etc. And lastly, the students have a chance to make a real contribution. Last year, the winning team from Baldwin, Kansas, came up with a new method of analyzing the design of a plane to reduce the number of candidates. Last year we were working on the tail section, and their approach to automation of that choice process was not yet used in industry. And so Cessna and some of the other companies are now adopting the students' process to help reduce cost and increase profits. So that's what we mean by innovation, and we're seeing that, and it's also a contribution that the students are making. Let me tell you a little bit about the process of the challenge itself. We have mentors providing support, so we don't expect the teachers and students to know everything about aeronautical design, engineering, or any of the content areas. We assume they're starting with relatively near ground zero knowledge of a lot of those things. We know that many of them don't know a lot about the software, so the mentors provide content support in science, engineering, and mathematics. We have a technology team that provides support in terms of software use. So we want to provide the teacher and the intellectual resources needed in the classroom to support the teachers and the students, and be role models for the kids, and professional development support for the teachers. So we have a statewide competition, which is the Governor's Challenge, and thank you, Governor, for allowing it to be the Governor's Challenge here in Rhode Island. And students and teachers compete to design a futuristic, in this case, a futuristic wing of an airliner. Those that compete will be recognized, and then a state champion is identified through a rigorous process of peer review and judging by professionals. The state winners from each state then are invited to go to the national competition in Washington, D.C. We pay all the travel expenses for the teacher, the state coordinator, and the students to go to Washington and compete in the national challenge. It'll be a more sophisticated version of the state challenge. And then they compete there. Again, once more, peer review process. The students are required at the national level to do a presentation before professional engineers, twice. First, a group of challenge judges identify the top 3 teams, and then the blue ribbon judges, who are significant dignitaries, identify the national winner. And so the students really get a chance to engage in that professional process, not only of design, analysis, and management, but they also experience the process of peer review. So it's much like doing a contract for a regular company. And so the challenge is free. Teachers get $1 million worth of professional engineering software. We encourage all teachers and students in the state to engage. Sign up is easy. They go to our website, www.realworlddesignchallenge.org. Takes about 5 minutes to sign up, and they're off and ready to go. And we're there to support you. Thank you very much.